Roman Barthelemy? Is that how I say your name, man?
Barthelemy.
Romer Barthelemy. I hope I'm right. Romer Barthelemy.
That's it. Thank you. And in there, things. That's it.
Oh, yeah, that's easy. Yeah, there you go. You nailed it.
Better.
Yeah, I think you're the smarter one here, so you only take one try. Where I had to rehearse this 4 or 5 times, and I still messed it up when we pressed record.
I don't pretend it.
Man, thank you for joining us on the show.
It's
How are you, and where are you joining us from?
I'm fine, and I'm living in France in a beautiful place called Vallouise in the Écrin. This is where I'm living and working for Supair, the famous paragliding company.
And I think your background tells me that this is more or less your brain. What is it called? Brainchild workshop or something like that? Like, is this where you keep all your toys that you play with?
That's it. My office is full of a lot of tech things. I'm a tech enthusiast, so I like to build machine I don't know, lot of tech things.
That's so interesting, man, because usually I think of course, creativity can go in any direction, but paragliders are those kind of people that are not really into numbers and stuff like that. And they're just like more outdoorsy people who just want to go out and chase the nature and everything. But of course, once in a while, there are some people of your kind as well. So tell our listeners a little bit about you. Who are you and how did you become where you are at this time in life?
Well, where to start? In Supair, I'm leading the office called innovation. So working transversally in many aspect in Supair. I used to work for production. I used to work for torture bench for some materials. And some times ago, I started to work for the project called Skymate. So I came in Supair 7 years ago. And we are working for Skymate maybe 5 years. And before that, I came from the Internet of Things company and drone manufacturing company. So I'm a lot in, software development, embedded software development, electronic, and all stuff like that.
So you're a coder who likes to fly, basically.
Yeah, I'm a coder. I do, like I said, it's very transversal. So I'm doing a lot of things that has to go with a computer and also with electronic and also with sewing and also with mechanic. Every part of tech work I'm interested in.
That sounds like a lot, man. Must be a hectic lifestyle, no?
Sorry?
I'm saying that sounds like a lot of hats that you wear. It must be a hectic lifestyle.
Yes. But I think in paragliding, we do a lot of such things. You are at the sewing machine and also at the designing machine. You do a lot of things in paraglider. There is no separated, I don't know how to express this, but
you're talking about a standalone role. Like there's not one single role. You have to be an overall person kind of a thing.
That's it. That's it. Yes, exactly.
No, it's quite a tricky market from what I see. And of course, the manufacturers, when I look at it from a business side, when they go out to hire someone, they can't hire people for specialized roles. They have to find somebody who fills in multiple, spaces and then of course keep it more streamlined like that. So I think that is where you're coming from.
Yeah. And of course, there is no school to learn how to design paraglider. For me, for example, I started building my own paraglider and kite. So this is maybe why I'm working for Supair now, because before that, I know how to assemble kite and how to assemble paraglide.
Okay, so tell me, how does that start? What does a person have to do when they have to start designing something? Is it just like take a pen and paper, start drawing, and that's how the visualization start, or is it mostly AutoCAD, or like what are the steps that you take to become a designer?
In fact, a lot of people think that it is impossible because when you start to think about what is a paraglider, you have to say it's mainly made of materials. And when you start, you have to start somewhere. You have to begin a project. For example, you start a paraglider. You say, I want to do a certain paraglider with, I don't know. For me, I start with I can fly machine. So I say I want a small wing because I don't want to buy one. I like to build by myself. So I start and say, well, what could I build for the first machine to fly and to learn how to do this. So I start to pick a profile and put it on a specialized software I was working on with a friend that were called FW Design. And so you put your profile, you start building the sail. and you do the export. With the printer, you print everything on the raw materials. You cut it, you sew it, and you put it in the trash bin because it's not flying and it's.
Yeah.
But
I mean, it's scary
but
to think about.
no, yeah, the first one always goes to the trash bin. It's the same for kite. It's the same for, but you learn a lot of things. You learn that the point were not at the good position. You learn that the sail tension is not the good one. So you start another one. And the second one is flying far better. And this is, where it leads you. So after that, you start a third one, a fourth one, and that's it. That's how I do.
Yeah. I mean, hit and try is the way to move forward
Yeah.
in life, You don't learn until you try hard. What I'm wondering is, does this help you make a better pilot out of yourself?
I think so. Because I know from the inside how it is made. When I see a production paraglider, I can see clearly how strong is it. Because when I did it by myself, I know that what I was doing was not maybe sometimes strong enough, but enough to do some test flight. And I know how it is made and why it is as good and why I can fly it and feel it in the air.
Wow. And that you can only learn if you start designing your own wings. Like, you can't read a book or, talk or listen to a podcast like this and get some visualization of it. It's just by going out and giving it a shot.
I think you can. I think it's going faster this way. Of course, you can learn by flying. There is a lot of, there's a lot of way to learn how to fly and feel if you can fly a lot of ground, a lot of paraglider, a lot of different things. I think you learn faster. By coming from the inside, you will learn different things, I think.
Interesting.
Yeah.
I think internal structure is something that we all as consumers completely ignore. We want the deepest things that we go in is the arc shape and the line attachment points and the material usage, because that's what is being marketed by the manufacturers. But internal structure is something that nobody even thinks about before choosing a wing or trying to get into that aspect of flying.
Yeah, but I think it's the main aspect of a paraglider is how it is made inside, because it does a lot. The internal structure is what is maintaining the sail tension, is what is maintaining the wing in all these aspects. And especially when it comes to, G maneuvers or something like that, it is what makes the wing behave like it behaves. It's not only the profile or not only, in fact, it's a wall. There is a lot of things for the line, the point attachment, but the inside structure is very, very important.
Wow.
I heard,
fascinating.
I heard Luc Armand state that it's all about internal structure.
So when you go out as a pilot to choose a new wing and you want to increase your knowledge for internal structure, how do you start reading it? For example, let me compare it to line attachment points. You know how the difference in behavior will be if the points are closer to the opening cells or if they're further. And same for the arc shape. Like, that tells you a little bit about its behavior in glide and the spiral behavior and those kind of things. But internal structure is something that is not even talked about pretty often. And I think this becomes a topic for one of the future podcasts. But how do you learn and grow your knowledge about internal structure so that you can make constructive decisions next time you are going out there and spending your money?
For me, in Supair, I'm not designing the wing for now. This is Pierre Valois that is doing the wing in Supair, but I try to help, especially on this aspect, and I'm doing it engineer way. So I take every element in, how do you say in English? A computer-aided programs that can take the tension and say, with this kind of attachment, you will have this kind of deformation of the wing, the whole wing, to see how the internal structure is working, in which direction, and how the sail tension is moving from the center to the tips of the wing. For me, a good wing is a wing that you design in 3D and is the same in the real life. So it's handling the same way. In the real life, the tension is equally respected. The tension is in the good way, and there is no shrinking or expanding of the tension. So that the wing is in every aspect the same as the one you design on the computer.
Okay, so you're telling me the manufacturing part should match the visualization in the graphics or in whatever software. This is so interesting, man. I just want to keep on coming back with questions, but I think we'll miss our topic of harness today.
I'm looking at other company, what they are doing, and I was very impressed by what was doing Tom Lillis and Carbona in BGD, because they were further and far away from what I'm doing, because they were going to the raw material, to simulate the raw material. And I try to do it, but in a simple way. I try to have simple elements, simple beam structure to see how it behave with the tension. But I'm always looking at what the others are doing. And I think it's a good way to do. But paraglider, it's not only science and not only computer aided software. There is a lot of agreement. The wing has to be good to fly. It has to be nice to fly. And you can build a wing with a very high aspect ratio that could fly at, 20 of gliding ratio. But it won't be terrible because it will, collapse very easy or stall very easy. There is a lot of room for empirism and manual development in paraglider. And it's a good thing, I think.
Indeed. It reminds me of this YouTube video that I don't know if you have seen it or not. It goes by the name of Deathblade, where this crazy aspect ratio wing. Yeah? Have you seen it?
Yeah, of course. Yeah. It's an old one. I think it's 2007. It's very old video. I think this is why we are working as a team, because we have a lot of test pilots. When the first wing came out of the computer software, it is not as you would like to have it. You have to work on it manual way every time.
I think one of my mentors told me that designing a wing is, of course, a whole different mountain to climb, but even trimming a wing needs a lot of visualization of the profile and understanding it. And that itself is quite an art, which you have to learn by experience and, by being around the right people and trying and understanding.
That's it.
Wow.
But
it seems like a lot of hard work that goes on in our industry that we don't even know about as users. We just go out there, browse through the website page and just spend the money and start flying it.
For sure. And, it's kind of secret. It's normal. The resource, there is not a lot of designer. It's a small world. You have to keep it secret because it's very competitive.
Yeah, 100%. Talking about keeping it straight, I think let's get this episode back on track. For the reason why we have joined, because I don't know, I love going on a tangent in such kind of topics, but of course, we are here for your absolutely magical product that you have. But before we dive deep into Skymate, Romain, one simple question that comes to my mind is, so many paragliding manufacturers out there who manufacture the gliders, but handful of harness manufacturers. Why is there such a big difference in people investing in the R&D when it comes to wing, but only very few getting into harnesses?
Yeah, it's not a simple question. I think it's because the harness is not the piece that do the performance. The main performance came from the wing, and I think the harness is just the appendix of a paraglider, and that's all. Because well, in fact, not really, because with the submarines, we came with a really increase in performance. In fact, I don't know. I have no easy.
What's the kilometer per advantage that you get from the submarine style versus the normal pod with the fairing style?
From the measurement we made on computer, it's nearly 1 point of gliding ratio, but in the real life, we are near half point of gliding ratio, something like that. It's starting from a good harness, from a foil harness already.
One more time, what did you say?
Yeah, starting from if you compare between a foil harness like the Delight 4 Sport and the Alp, for example, you gain half a point of gliding ratio.
Okay, so basically a normal pod harness with fairing compared to the submarine styled harness, it's half a 0.5 glide ratio increase. And what's the speed increase? Like, do you, if you're, let's say, you're trimming at 38, how much are you trimming at with the submarine style?
I don't remember. Sorry. We can do the math.
No, I was just approximate. Does it make a substantial difference, or is it very negligible?
I don't want to answer because I don't know exactly, but it's half point. We measure it. In fact, we measure it in terms of charge, of drag. Between a normal harness, we have nearly 12 Newton of drags on the harness. And with a submarine,
You mean
we are
chair
nearly,
harnesses?
like a foil harness, like
Okay, the one with the fairing, yeah.
for example. With a chair harness, we are nearly like 23 Newton, I think.
Okay, so you cut it by half.
Yeah. And with a half harness, for example, we are nearly like 8 Newton. So we gain a third of on it.
Interesting.
Yeah.
Love it used to baffle my mind, because I'll tell you why. I started comparing this with the cars and how the shape of normal automobiles have evolved over the years. If we look at the designs that the manufacturers were coming out in 70s and 80s, you saw the cars were a lot more fatter. They were a lot more round, and they were just like a bit bulkier. Fast forward to today, you see the cars a lot more streamlined with these, like sleek looks and like channelizing the airflow and stuff like that. My curiosity stemmed from the fact that we look at any fairing harness, like be it XR7 or be it Delight or be it any of those have a much less surface area exposed to the wind. The cross section is what I'm talking about. If you look at it from the front,
the cross section is nearly the same, but you have the drag coefficient. So because the drag coefficient is less than on air chair harness, you have less drag. It's just aerodynamics. It has better aerodynamics. I think the Alp has a bigger cross section than the Delight 4.
Yeah, that's what I'm wondering. That if it is having a bigger cross section and the point where the fluid, in this case air, is making contact with the fabric is a lot more, then of course, we are trying to reduce the contact of, we're trying to pass through the medium with least amount of contact so that the drag reduces. So then how is, this doesn't make logical sense to me that a bigger cross-section area is having less drag coefficient. Can you please explain that to me?
Because of the shape of the harness. Because the flow is going smoother on the shape of the harness, you gain a drag coefficient. So a drag coefficient is the representation of the good aerodynamics of the harness. So if your harness has a longer shape, for example, it will have a better drag coefficient because the flow is going smoothly on it. If you have a straight curve, just a flat curve at the back of your harness, there will be turbulence, and this is dragging a lot.
Fair enough. Help me understand the design of Formula One cars.
Formula car is there is two aspects in Formula car or car in general way. There is the aerodynamic of the car, so it will drag less, but there is also the pressure you put on the car to put it on the ground to have a better adherence during driving. So it's not only the aerodynamics. In paragliding, for example, you only work on aerodynamics because this is what you want to reduce. You want to reduce the drag coefficient. That's it.
Right.
On a car, you want to reduce the drag coefficient, but you want also to have strong force on the wheel to be able to drive fast in curves.
Wow, this makes a lot of sense.
Yeah.
And I think that is why, let's say, commercial airliners are designed with a more round look rather than fighter jets.
And for now, when I see modern Formula One cars, there is a lot of wings and winglets that came from everywhere to be able to stream the current on the car at specific points. You have to cool the engine. You have to put this weight on the car to put. So there is a lot of appendices that are coming from everywhere to help the car be faster and to be strong on the road.
No, this is what was baffling my mind when I started looking at the designs of these submarine style harnesses. Because let's say Supair's Alp is a very clean, no nonsense kind of a harness, just pure kind of balloon shape without any protruding parts. And then you have Ozone having a fin under the fairing, and then you have Nevio coming in with two fins, one on the top, one on the, and then of course Woody Valley is doing their own thing, and some other brands are having their different fins at different places. So how is having fins in this shape helping when we are trying to just make sure the flow is completely uniform? Because of course the fins are going to disturb that, right?
Yeah. Yes and no. In fact, the fins are disturbing, but also they are making a motion that will help to have a better drag coefficient. The fin for me on the submarine, or the original submarine of Ozone, I think is made for high speed stability, because this submarine is made for competition. So when you are coming at high speed, you will start to have some instability that occurs on the submarine. And I think it's made, I'm not sure. Huh? This is my thought. For us on the Alp, as it is a I can fly harness, we don't want it to be flown like high speed harness. It is for increasing performance on the whole speed range of I can fly wing. So we want it light, and it is not meant to be at high speed every time. And the submarine is different for me in this kind of.
Wow, that's so interesting, man. Because what we see, I mean, of course, these are all behind the scenes that you as a designer see so easily, but as a consumer, just read.
It's not easy, because we have to think of what the others are thinking. You know, because like you, we were wondering, what is this? Why putting such thing on such NPDs on the harness? And we thought that it was for stability, because we try it. We made a lot of prototypes. We made this, and we say we will need it for high speed. And for example, we have a version of the Alp for the X Alp, and it has a fin, because for the X Alp we have to reduce the size of the fairing, because it has to stay in certain lengths. So we had it able to have a better drag coefficient on a small size of a sublight, for example.
This was another question that I wanted to ask, is when it comes to fairing, is the longer the better?
I think so. I think there is an optimum, but because if it's longer, I think it will be wider, and after that you will have something that is not very easy to take off with, and but at some time you won't gain enough to have something very long that will don't need anything. But I think so.
I think the longer, the cooler for sure, because it looks better. Like the harnesses just look sexier when they have a longer tail behind them.
Yeah.
They're good for the photographs.
Yeah. But we were also working on some, drag limiter for the arm, for example, because the arm are doing a lot of drag during flight. So do the riser. So we were looking at doing some appendix to reduce the drag again on the riser and on the arm, because this is maybe the last thing we can work on it to reduce before being in a wall canopy completely closed.
Yeah, I was literally gonna say that. I think 5 to 10 years from now, let's say 20, 30 or early 20s, we are definitely looking at closed canopies in paragliding. Yeah, I think that's where the industry is going.
Yeah, I think so. But it have to stay light, and it's paragliding. Paragliding is not only performance. For me, I enjoy ball bivouac or something like B-flight and something like that. So the paraglider is not only competition.
I mean, look at how we have come, Romain. We started from these skydiving looking ram air canopies, which were just gliding down at 3-1 or 5-1. And of course, back then also there must have been a school of thought saying that, hey, it's not performance. We just want to enjoy the freedom of soaring around or roaming in thermals. And today we are chasing, distance with triple Cs and coming out with innovations for increasing half a point of glide ratio, as you said. So I think somehow industry will go where the money is, and the money will go where the comfort is, because audience eventually pays for the comfort, right? And if closed canopies and pressurized systems and those kind of things are increasing the comfort, because you look at the technologies now in our flying wings, there is RAST from Swing, which is making it easier to fly a wing. There is what did the Diva have? The Reflex, which is making it easier to fly.
Yeah.
There are Shark, what was that thing with the gin, the wave leading edge, which is making it more collapse resistant. So the industry is subconsciously or knowingly going towards making it easier to fly the sport of paragliding. And if having a windshield or a closed canopy is much easier to the pilots, then majority will eventually go towards there, and then the industry will follow, because that is where the money is, kind of a thing.
Yeah, for sure. For sure. But for me, I'm thinking that with it's always a run forward. You are always running for more aspect ratio, higher aspect ratio and new safety features, passive safety features on the wings. But we are missing the ability to extract 100% of what a wing can do. This is one of the things we try to make with Skymate, because we are trying to get the maximum of B and B glider in terms of performance by helping the pilots to go further with such level of performance. We are trying to reach an ANC glider with an ANB glider.
Wow. So it is making flying easier, or is it making flying more efficient?
Easier, better. In fact, we are trying to have high level of safety by using an ANB. We are trying to have the high level of safety, and by helping the pilots, we are trying to make it fly better.
Okay, amazing. Well, thank you for mentioning Skymate. I'm so glad to come back to this topic that we joined here for like half an hour into this talk.
Yes.
No, like you're such an interesting guy. Like, I can bring you on for like 5-6 episodes. I think we should do a series on the brain behind. All right. Before we dive into this, Romain, I was reading the brochure that you guys put on, and there was a very interesting thing over there which you mentioned. The European Commission has a project called PERF AI. PERF AI, which is basically focusing on applying machine learning tech to the flight data. Could you please tell our listeners a little bit about this project and what is it all about?
To be frank, I don't know this project, but in fact, to say this is the way, because with Skymate, we will have access of a lot of data, because we will collect, and this is what we want to do. We want to extract rich information from all this data. And we want them to be how to say it? I don't know if it's a good term, to be able to help pilots to fly better and fly safer, especially safer.
So let's say, how did this concept start? Like, tell our listeners a little bit about the history of how the origin of Skymate look like.
Spoiler alert, was not intended to be such a big thing with artificial intelligence or something like that. When we started Skymate with Laurent, it was an idea of Laurent that asked me to think about a project.
Laurent is your CEO, like he's the boss of all things at Skymate.
That's it. Laurent Chabot, CEO of Supair. And he asked me to think of a project to have better safety in paragliding. And because we came with data that were made, that was given by the Federal French aviation, and they say there were a lot of accidents, and sometimes there were accidents where the pilot didn't do anything. For example, auto rotation, we had when we start, it was, I don't know, 16. There were 8 people that were into an auto rotation and were to the ground without doing anything. And he said, what can we do to avoid this situation? What can we do to prevent or to do something for the pilot not to going down after an auto rotation? So we started to experiment. We made a lot of experiments. We tried first a passive system approach. So we didn't want to put electronic at the first time on the paraglider. We wanted to have a system that is passive. So maybe the pilot could pull it when something is going wrong. Very quickly we came to very quickly we see that if the pilot is fighting during an auto rotation, collapsing, or I don't know what, man driving system won't work because he won't pull it, or he will have pull the reserve instead of going down. So I said to Laurent, we have to put electronic, we have to measure, we have to act when the pilot is not acting. So, and when we opened this box, it was a huge thing because we have to do lot to this.
I think this reminds me a little bit like the AADs in skydiving, the automated activation devices. Is this like inspired from that kind of a thought process?
Yeah, of course. Yeah, exactly. That's it. So we wanted to see what we need to have it. And so I started to look at some devices to measure G meters, to measure auto rotation. So we start to make auto rotation. We start to do a lot of tests to see what is necessary on such device to be doable. And after that, we see that we need a strong link between the difference sensor because we will have a lot of sensors that are in different parts of the harness and the wing. So it's making the thing harder because when you have a different sensor in different way, you have to power them and you have to do data link communication between them. And this is where the fun begins. You have to do something that is simple enough so that the pilot don't need to wake everything up. We want it to be very, very simple. Puts its harness, he closes the speed bag and everything is running.
Yeah. I mean, just making life easier in the air for all of us. Yeah, that's what machine learning is all about, no? Or that's what they tell us.
Yeah, no, but there is a lot of different layers in machine learning. You know, artificial intelligence is very wide. That come from very simple algorithms to very sophisticated, different of layer machine learning. When you say artificial intelligence, it's cover a lot of things. What we did, we started with something simple, but very upgradable. So we are thinking on starting with basic detection. And after that, when we will have collected enough data, we will the system is able to handle higher level of artificial intelligence.
Of course.
It is upgradable.
What I'm wondering is that did you guys have to make all the data points to collect them for research in the beginning, or was there some reference points already existing in the market from other industries like automobile, aviation, and stuff like that, where you could just buy that data and implement it into the system so that there could be some kind of algorithms designed around it which could help you start the development?
No, I didn't find any data on the market. We have to collect them because it's very specific. For example, I started with some data collected on the Federal Cup of Distance in France to be able to have some first point to do some tests. Especially because, for example, in Skymate, the system know where it is at every moment, at which altitude it is above the ground. So I have to try with already recorded traveling to see if I have trouble in my detection and if it's going to work on the system without doing a lot of flight, because it's very consuming for the pilots to fly for nothing. It's just fly and see if the data is good. It's not a very easy task. So we used already data that has already been recorded.
I'm wondering, this must be quite a humongous task because this is just one aspect that we are speaking about. What's the timeline from the drawing board to final first proto production kind of a thing? You know, how many months, years, or whatever, if you're comfortable talking about it?
Yeah, it's 5 years.
Holy frickin' moly. When did ChatGPT come out? Because we as consumers only knew about AI after ChatGPT, right? Like before that, it was just like working in behind the scenes. It was never given to the end user.
No, but it was already there before. It's not something new. This ChatGPT came and it put in the foreground something that is new, but it has already been here before. So no, it's 5 years of the artificial intelligence is a big stuff, but we keep it for further work because
keep it
for further work for the future. For now, we are using a very basic AI detection model because we want the electronic and the system to be extremely strong. After that, we work on artificial intelligence. The priority is to have something that is durable, that's something that is repairable. So the pilot is easy.
That is what I was coming to next point as well, because, tech of today is rarely repairable up to a point where it can be used again. We're in an economy where it's like use and throw and not repair and reuse kind of a thing. But in paragliding, which takes so much money and investment from a pilot, what does the reusability of a harness like this look like, and how does repair possibility of such a sophisticated product look like on the market?
For this product, we want to have it's like premium. This is the first product. It costs a lot. For the start, we want to have a year of maintenance, for example, and everything which will be repaired like a premium car or like premium things. Further, we will decline Skymate technology on the mainstream harnesses. But for a start, everything will be repairable, replaceable. The whole harness will be will be repairable, and so does the wing.
I'll tell you what scares me, man. Imagine somebody finds enough money, I mean, because the moment this product is going to come on the market, everybody's going to want it because of the, all the like things that is going to, like all the noise it's going to create.
Okay.
And then, like, I hope so, because 5 years of an R&D, man, you guys deserve that kind of a response, at least, I think.
Yeah.
But what I'm curious is, somebody buys this, and then for some reason they have to get the repair done, and they're like, no, I can fix this myself. Like, that is the technology. That is usually the mindset that we have for a lot of other products where we want to save money. And if there's somebody who kind of knows a little bit about soldering and playing around with the motherboards and stuff like that, tries to repair it, messes it up, unfortunately, unknowingly, is there a possibility that this could go rogue? That, there are accidental deployments and like false detections, and like something from the iRobot movie where if you play around with the robot, then the robot tries to kill you or something.
I won't laugh at this. I don't think you can't have access to the electronic. If you try to repair by yourself, it will be seen. It's like any other thing. If you try to fix your car by putting some duct tape on a tire, you will see it, and the insurance won't work for this.
I kid you not, man. Somebody is going to try it. That's how it works. Like, people are curious and they want to dive deep into it.
Yeah, I'm pretty sure that there will be men that will open it and will look in it to see how it is done. It's okay.
I think the first will be your competitors, buying a harness and ripping it off and doing a reverse engineering.
Yeah, of course. But I'm the first to do this. I'm the first to look inside and see what's in it and how it's works. So for me, it's a non-problem. But if somebody is trying to change something in it, and it is his responsibility, it voids the warranty.
You're doing your part by giving out a finished product, and then it's up to the user how they want to use it or abuse it. What I was curious is, like, let's say the Boeing algorithm with the 737 shit that went down. Well, what was it, MCAS or something, where it was just a software update which they didn't provide, or some training and those kind of things. So what I'm saying is, when you write a code, there are endless amounts of glitches that can come in the beginning, maybe during the use case scenario or whatever. So the moment we are giving that aspect of safety to machine, the possibilities, of course, we can limit them, and there is various safeguards around it. But do you see even a tiniest bit of risk factor? What is your take on that? Like, what is your take on things having an undesirable outcome because it is machine and not human?
The only thing we can do is we conduct a lot of unit tests on every aspect of the software. Of course, we put a lot of redundancy on the system, so that for when you have to act, it will act, and so something like that. For example, the automatic parachute, if you want to pull the parachute, we have two systems that will pull the parachute. Like in skydiving, there is a rescue handle, and there is a side press that will open the parachute on the system. The only thing we can do is test a lot. And what we are doing also is conducting tests on the data we have already recorded. And for the first, let's say, years of using the Skymate, we will collect the data and we will replay all this data to the system, to a bench system, to see if there is corner in the data. So we will replay, and we will update our system on the data we have collected.
That's so interesting, man, because usually this kind of R&D was only in high-tech aviation or F1 or like those kind of performance, but seeing it come to paragliding kind of blows my mind already.
In fact, it's coming in a lot of different sports. It's coming in biking. It's coming in a lot of things like that. So yeah, it's a way it's coming for every sport. And we have to start somewhere.
Maybe I'm just thinking about this. Maybe if sensors like this become the norm in next 5-10 years, where, there are more people like you out there developing things, I think we could actually try and improve the performance of an athlete by looking at how their behavior is while turning or coring or choosing the lines or gliding, and, usage of pitch control and usage of B handles and those kind of things. Like, this is very interesting. This is a whole new tech side of things which is going to redefine the performance in paragliding, I believe.
Yeah, I think so. So this is something we have in head. We are thinking of such thing. But first, after we will talk about performance, but first safety.
100%, man. Let's talk a little bit about the product itself, because I'm looking at the diagram on your brochure here, and you have a lot of sensors at various attachment points. Are these the same sensors that iPhones and, the latest mobile phones or similar sensors which are being used to do crash detection and those kind of, which are like basically detecting a difference in altitude, pressure, and those kind of things?
Yeah, it's MEMS. We have a attitude sensor. So it's a mix of different sensors like accelerometers, gyroscopes, magnetometers. So, for example, there is one in the harness and one in the wing, because it's needed to be able to have a real detection for auto rotation. Only one sensor is not working. We conduct a lot of tests with only one sensor, and we are not able to make the difference between some kind of 360 and auto rotation. So we had to use two sensors. We have barometer for the altitude. And because we have all the sensors, we can combine them to feed the different instruments and the different safety box. For example, we wanted to have, we don't want to have multi bricks. For example, when you are flying in competition, you have 2 GPS, maybe 3. You have sometimes a variometer on your helmet also. So we want the data to go to all the systems, and all the system will take the data and have them as a whole. So they can pick the GPS coordinate to feed the variometer, or to feed the altitude sensor that is given to the safety box, for example. Everything is mixed.
So you're basically collecting all of these data points and aggregating them and then processing them and then coming out with a conclusion.
That's it. And every part of the Skymate have access to all the data.
Wow. Okay. A question comes to my mind. Like, let's say, this is just an article that I read that Google collects, I don't know how many thousand data points on you when you're browsing their website or just scrolling on their phone or something. Do you guys have a number? You don't have to let out any secrets. Of course, this is pre-release of the product. But how many data points are you collecting at any given point of time, at any given second during the flight?
I think it's 100. I think so.
Wow,
but for now, but it's for development. Later, I think we will reduce them. Maybe by 10 bytes seconds, it will be enough.
100 data points per second. Jeez, that's so interesting.
I can see every movement of the wing at any time. It's pretty interesting. You have some data that are very, very nice.
You're having a gold mine of data in paragliding with you right now, aren't you? Imagine selling this to the market. Like, this is like worth millions. I think so.
I don't know. I'm not thinking like that.
No, but okay. So is it just like few sensors, or do you have multiple sensors in the wing?
In the wing, there is only one sensor. It's attitude sensor. So we have, in fact, it's a bunch of sensors. So we have accelerometer, gyrometer, magnetometers, and attitude sensor that came with, how to say, it's a solution in terms of positioning. So we know exactly how the wing is gliding.
And is this like a system which is compatible with any wing in the market, or does it have to be Supair wings?
No, for now, it's only for Supair wings. It's a question that has been asked a lot for me. Can I take my wing and have it to fly? I say no, because we need to know the behavior of a wing. So maybe later we will put some sensor on other wings, but we will have to conduct a lot of tests to know how the wing behave, because it's not just see how the wing is going into auto rotation, see how it is behave to have the better performance of it.
What's it called? I mean, you guys have copyrighted? No, it's not copyrighted. What's like the thing which makes it exclusive to you without even
for now? What is your question?
I'm forgetting the name. Like, it seems like you guys have copyrighted this technology without even actually putting a copyright to it, because of course it works only in a system. This is like Apple. You buy an Apple iPhone, then you have to get in the whole ecosystem to get the most out of it. So I think it's kind of similar. Like, you buy a Skymate, then you have to buy a Supair wing to make sure you get the maximum performance out of it.
Yeah, for now, it's a pack. The harness come with a wing, and it's not separable for now. We have in mind to open the protocol for Skymate to be able to add other sensor, because it will come in time. We will need I don't know, a pitot tube or something like that on the harness, and we want to be able to be expandable. We want the system is working on only one battery. So everything is powered by only a unique battery. So you can expand on we call it a bus. It's data link on the bus. You can put another sensor on the bus and have communication with another sensor that is on the bus. So you can add, I don't know what you can add, maybe a camera or something else. You can take picture of the collapse when it comes. But for now, it's prioritary. That's it. That's the term. Prioritary? No, I don't know.
No, one more time, slowly a bit.
Prioritary.
Okay, something pre-protocol. I'm sorry, man. It's just like your French accent of rolling the English word, making it hard for me to understand. But everything else in the show has been clear so far.
It's been a long time. I didn't speak English. Sorry.
You're doing amazing, man. No, but like what matters is I think this reminds me of a conversation with Honor, and he was one of our first guests in the show, and he said, "I'm sorry, my English is not good." I'm like, "Forget it, dude. You fly better. That's what matters. English language does." I do face this dilemma a lot of times while bringing Frenchies and Germans and stuff like that on the show, because of course you guys are the hub of paragliding R&D in a lot of ways, where most of the research and development is happening in this region. But getting it out of the guests is always a bit of a catch-22 when it comes to speaking, but no worries. No worries. One thing I forgot to ask is, of course, this is something that improves with time. And as you said, data, and the more people that use the system, the better it will get, because it'll have more feedback to work on. But how is the accuracy of these things right now in your simulations and in the field tests that you guys have done?
We are conducting a lot of tests for example, I will just take an example. For the auto rotation, we are conducted a lot of tests for auto rotation. We have a very good discrimination between an auto rotation and anything else, because it's not only 360 or SAT or anything else. If just the man is working with the harness on it and the parachute goes out, it's not working for us. So we now have very, very good data that led us to see that we will have a strong link between our sensor and the auto rotation.
Wow.
Very strong.
And is auto rotation the main, kind of collapse that it looks to detect, or asymmetrics and stuff like that also activated to a point where it gets ready to be in the deployment mode if needed?
No, for now, the deployment mode is only on auto rotation and maybe twist. We will see later what we will do with twist, for example, because we are able to see twist in the air. But for example, for the auto rotation, as we have a collapse sensor, we can know before the rotation occurs if the wing is going to auto rotation or not. In fact, we will be ready. If we see a collapse, we will be ready if the wing is going to an auto rotation fast before the pilot knows.
Wow.
Because in auto rotation, the main issue is that there is a cravat, and the cravat is going to an auto rotation. So if we see a collapse and we see nothing and the wing starts to spin, we are ready. And we are ready to send a safety notice to a rescue team. We have a company that will be working for us, and they receive a safety notice that say it may have an auto rotation here at this point, send rescue at any time. At the first time, when we see a collapse and the wing starts spinning, we send a rescue notice. If the pilot get out of the auto rotation, we cancel this notice. But if not, the rescue team is going.
Mind blowing, dude.
Yeah, because we want to send the rescue notice as we have connection. If you are high, you have connection. If you are low, maybe you lost the connection and won't be able to send the rescue team a notice. And it's better to call the rescue team. Sorry.
The connection is the phone, like the GPRS, like 3G, 4G, 5G, those kind of.
Yeah, it's 4G. Yeah, it's 3 and 4G connection, and it's a worldwide connection, and it's taking the best network on the connection. So we have agreement with I don't know how many country, but it's nearly the world. So we will send a notice in the world, and the rescue team will come if you are in trouble.
Okay, but the only limitation that I see is that if you're having big mountain flying, let's say in India, Billing, the Himalayas or the Karakorams or, places which are a bit blackout for mobile networks, then it could be a bit of an issue. Or do you have something like Garmin which connects directly to the satellite and then provides something?
We didn't went to the satellite for now, for example,
Okay.
because there is some corner case also in satellite connection, because the antenna has to be on the top, has to see the sky, and the costs are very, very expensive for such device. But this is something we plan on adding later.
Yeah, I think that's what I was saying. Maybe you come out with Skymate Pro Max or something.
Yeah, this is something we want to try. The first try I made, I say, it's very expensive and it has its own limitation. And if we already have a strong 3G connection because we are operating on the better network we can find anywhere in the world, it's already a huge safety feature. In the Alps, for example, you have a coverage maybe anywhere if you are
almost everywhere in Europe.
Yeah, almost everywhere. And we are able also to switch one of the transceiver that is used for Flame, for example, into LoRa mode and send LoRa feature or LoRa beacon on the network. So if there is a LoRa gateway, LoRa?
I'm sorry, please enlighten us a little bit.
Okay, so LoRa is a radio communication devices that can send LoRa transmission at a very low bandwidth, so a very small package, but very, very far. It's been known to be able to have 500 kilometers of transmission length in the air. And in the Alps, we have a lot of projects that are working on this to make safety beacons and safety rescue. So when we have an incident, it will switch to LoRa and try to reach a gateway that is close to you.
Wow. Interesting. Very interesting. Yeah. Another thing that I was curious is because, of course, your harness said that it has an automatic startup. What is
automatic what? Sorry?
Automatic startup. Because it says under the heading optimized flight experience. So what does automatic startup look like in a paragliding harness?
We wanted the system to be extremely simple. We don't want the pilot to dive into setup, configuration, or anything else. When the pilot put his harness, when he closes the speed bag, the system starts. Ready. That's all. Nothing to do.
Pre-programmed all the steps that are needed to take out any redundancies. Like just buckle up and then you're ready to take off.
That's it. And when you start, is checking that your harness is closed, that everything is okay, and you are ready to fly.
This is fancy, bro. I kid you not. So I want to review this harness already. Like as soon as it comes out, I would love to bring out the awesomeness behind it out to the audiences across the globe. But yeah, you want to talk a little bit about the main board, because I think that is the only thing that is left right now. Is that basically a motherboard that you said, which is connected to a battery, and that is where it processes every information?
So the system is made of 4 boards. There is 4 electronic boards in the whole system. They are designated in different way because we try to make it in only one or 2. One in the wing and one on the cockpit, but it made the cockpit very heavy. So it was not very easy to fly with it because it was too heavy. So we split it into 4 boards. We have main, we call it safety board. It's the main processor. It has all what is needed to calculate all the safety features. So it aggregates the data. It is speaking to the other board and it is operating the other board, say, you do this, you do that, and everything is going like that.
That's the boss of all things in the harness, basically.
Yes, it's the main board. It's really the main board that is directing all the other board. And the other board, on the other board, we have a cockpit. We have also a display that is connected to the battery and doing the alimentation
calculations.
To deploy the airbag, to deploy the automatic parachute, and And the last one is a small sensor board that is in the wing.
Damn, bro. This is so much tech. That was like unheard of in paragliding. You guys have motherboards in 4 places. Shit.
And everything is connected together on special data link, PowerEd and data link on the same wires.
Is it like Corioid? The protector
Sorry?
Corioid? What did you say? Corioid?
No, not correct. Not everything is connected on the same wire. And there is only 2 wires that are doing the powering systems and data.
Okay. And is this like, is there a wire going from the harness to the wing as well? Because obviously I think the risers. Yeah. Okay. Yeah. So basically there is one tiny wire going along with the risers from the wing to the harness. Yeah. Okay. Okay. One thing. Honestly, if you can't answer, what are the chances of breaking one of these boards if you have a hard landing?
No, in fact, they are well protected. The main board, they are in a case, in a plastic case. So the main board, I don't think you can break it. The board that could break is the one that is under the seat if you do very, very hard landing, but it's over the mousse bag. So I don't think you could break it because it is in a plastic case. It is well protected. We try to make it water resistant also because maybe there will be some pilots that will do some SIV stuff to test. So we try to have it the more water resistant and weather resistant.
Yeah, that was my next question actually, because let's say if you fly in clouds, one thing we have seen that the digital compasses fail quite often because of the static charges that are there in clouds. So how does this system, although I mean of course it's all wired up, so it's a lot more robust than the usual Varios that we have, which are just running softwares, but how does the accuracy of this system look like when there is charge in a cloud all around you?
Yeah, this is some tests we are conducting right now, but the sensor we are using use a combination of different sensor, and it's not taking only the magnetometer, for example, for having the cap, the heading. So if the magnetometer is failing, the sensor will stay for a certain amount of time at a good direction, or a certain amount of time. But it's not something, how to say, that is used. I could say in our detection, not rotation. We don't really need the magnetic north to detect the auto rotation.
Interesting. Yeah, I think it comes with a inbuilt, like as you said, GPS and stuff. So does it have its own screen which displays all the flight parameters, like glide, above ground, and speed and everything, those kind of things?
Yes, that's it. Yeah. In fact, the system has everything you need to fly. You don't need to put your gyrometer. You don't need to put your instrument. Everything is displayed on a small screen on the cockpit, and there is a connectivity with your smartphone, so you can use it with etc.
Isn't that all that a pilot needs, anyways?
Yeah, I think.
Love it, man. I think I'm running out of questions now because you've answered all of them so honestly. So thank you so much for that, man.
It was time.
It's very hard to come across people in today's world that are able to share unfiltered and transparent opinions. So, you guys at Supair have been kind enough to do that. So massive thanks.
Yeah, you're welcome.
The thing that I'm curious is that,
in fact, I don't know, maybe 2 years ago, I wouldn't have done this, but now we have protected everything with a patent. So it's far easier to do it now.
Yeah, patenting was the word that I was looking for that when we were having the chat of connecting it with the ring. So I was like, you have patented your technology even without, because it's only compatible with Supair systems. Anyways, to cut it short, it's like if somebody wants to get a whole package, just buy this harness and the wing that comes with it, and that's all you need to fly better. At least in the B class for now, I would say. Yeah.
And we will try to extract the better performance of this ENB.
Yeah. I cannot wait to see this. I think probably Civil or FAI will have to come out with some guidelines with this being implemented in CCC classes. But damn, dude, the amount of tech that is going to go into racing paragliders is like, that's mind blowing already.
We are planning on doing some try with our new Y2, for example, to see what we can extract from this wing also. For now, we are working on the different class in our product range, but after that, we will see. I think in competition, it will be a great thing, because like you said before, we know how is the wing at every time. We know what is handling, and maybe we can help the pilot to drive it better at every moment of his flight, to be able to maximize the performance, for example.
I'm just looking at your website, man. Like you're like the Wild 2 and that combination with Alp. That looks like straight out of a sci-fi movie. Like kudos to your designers. They have made such a cool looking wing with the harness combination and stuff, you know?
Yeah, it's very nice.
I think you guys recently refreshed your design on the wings.
2 years ago or last year, I don't remember.
They just look more sexier and racier now, for sure.
Thanks.
One thing that I forgot to ask is we are reaching a point in our daily lives where everything is battery based, you know, and of course that needs charging. You know, your phone needs charging, your car needs charging, and freaking hell now even the harness needs charging as well. It's like, do you have to plug in your harness before you go fly next day?
No,
like, how does the battery life look like on the?
In fact, the battery we will have 2 batteries in the system, and we have super capacity on energy. So when the battery is depleted, the system is still working for maybe half or an hour. So you are safe for half an hour. So you can change your battery in flight, and it's hot swappable. So you remove the battery, you put a new one, and it's flying. It's like nothing happened. And
like a power bank kind of a thing.
Yeah, that's it. It's kind of power bank, but it's going for maybe 10 hours. We are planning to have it to be able to fly for 10 hours so long without charging. And we have 2 batteries, so you can charge one and after use the other one, and that's it. It's hot swappable.
I think you guys should put a system which forces a user to charge their harness, because I kid you not, there will be instances where people forget to charge their harness and then they reach a point on takeoff where they're like, oh, I forgot to plug it in and now I have to fly without any of this. So I think there should be a system which forces them that if no charge, then no takeoff kind of a thing, like in some cars.
Yeah. After all, it's paragliding. You don't need battery to fly a paraglider. If he wants to take the risk to fly without all the safety assistance, he still can fly. And there is a manual rescue, so it is always in safety. We have the maximum safety features on this harness. So there is two parachute. One is automatic, one is manual. So even if the harness is not charged, you can fly.
And how does the cold weather protection look like? Because all these GoPros and early action cameras that came, the moment we used to take them higher up in the mountains, their charge used to run out like within 5, 10, 15 minutes. So how is the cold weather endurance of your batteries doing?
Yeah, weather. I have a trouble in the start because the battery was stopping because of the heat. The system is made so that the sun cannot reach the battery itself, so it won't warm too much on the inside the cockpit. So does for the cold. You know, it is packaged in. It's not in the wind. We tested in -10 degrees. It wasn't an issue. It wasn't an issue for now. But we have a lot of more tests to conduct. Now we are doing it now.
Always in proto mode. I think that is how paragliding looks like, you know. Consistently wanting to improve.
That's it.
It's nice. Wow, man, I think I have exhausted everything that I was curious about. Is there anything that you feel like we might have missed on bringing out this awesomeness to the audiences that are tuning in to know more about this?
I think we covered the whole thing, also.
Is there any target about how much money you guys are planning to make off this amazing product?
See it like a whole package. You will have the harness, you will have the wing, you will have the services for around 50,000. 15, not 50.
Holy shoot. How many Mercedes can come in 50? That's desirable, I think.
Yeah.
That's not too bad.
I can't say much on the price. We will try to reduce it at max we can.
Oh, I mean, nobody is in paragliding business for the sake of money, but of course we all need money to survive. Nobody can work for free as well. And I think anybody who is willing enough to put 5 years of hard work in a place like yours, where I can see the amount of toys that you have on the back, is like, that's a lot of brain work. You do deserve all the reward that you can get for it. Fingers crossed, man. I hope everybody listening to this episode is also having similar feelings.
Yeah, thank you very much. It was nice.
You know, I think before I let you go, Romain, I usually have this tradition of asking my guests to share
Yeah.
one flight from the carrier, but I mean, here we are talking about a specific product. So can you share one flight from the testing times, the test phase that was interesting enough for you, where you learned a lot, or where you were like kind of, whatever that you remember, which is the most important flight from the test?
I think the most important flight that came from the testing phase was when we were conducting a test flight for auto rotation, collecting data. And it was a day, a very cloudy day, rainy day. We were at takeoff. There were nobody else. We were there under the rain, waiting for a small amount of time to take off. And when we came back at the landing, take off the SD card from the system, and so that I have a great line of data that was showing me that we could discriminate auto rotation against 360. It was a great time. It was like a little sun that came out of the cloud, and I say, wow, it was not a bad day at all, finally, because it was all rainy around, and let's say we didn't come here from nothing, because it takes.
What was the reading that you said, the red line of data? I did not understand that part.
It was, we could discriminate,
Differentiate
the difference between auto rotation and 360. And it was a really, really good time this time, because
yeah, I think those are like eureka moments in every inventor's, where you just want to run out naked saying that, yes, I found it.
Yeah, exactly. Finally.
You could have done that. You were alone on the takeoff, no?
Yeah. But it was very cool to see that at the landing. You take your computer with the SD card, say, I don't want to put it to crash it. Did that work? Yes, it worked.
Were there any low phases in this development where you just felt like giving up?
Yeah, there is a lot. When you are conducting tests, especially stress tests, because the system, you don't want it to break, so you break it. Especially you're going hard on the test, and you say, oh no, another brake line. You have to dismantle the whole wing to put another one, to try another thing. And you say, oh no, another one. This one is not good enough. And yeah, this is very, very difficult, because you do it a lot of time. And yeah, mainly that. But this is how you learn, and this is how it is going to be better.
Indeed, my man. That's how you grow in life in general. So I think on that note, we will come to a close for this episode for now. But any final advice you want to give to listeners out there who want to get their hands on it? How and when can they expect this awesomeness in their lives?
Normally, we are hoping to release it this summer, but well, that's it. We are maybe on the final sprint. It is taking a lot of time. Please be patient. That's all I say. We are doing our best.
Love it, man. Love it. Thank you. Thank you so much, Romain. This talk has been very enriching. Let's have you back on the show once this revolution of yours hits the market and we have more data to talk on.
That's it. Thank you very much, Linda. It was nice. Cool to see you.